Hey guys, welcome. Yeah, so example 1 here, and if you have not already done so, I encourage you to watch example 0. It's the most important example. It explains why and how trig substitution works. Yeah, in fact, we got started with this problem here in example 0. And we discussed this table here in example 0. Now, even if you don't watch example 0, if you have this table handy, you should know that the appropriate substitution for this integral is to let x equal 3 sine theta. And if you do, then dx, first of all, would have to be 3 times cosine theta d theta. And then our integral will transform to this with this substitution, and therefore that other subsequent substitution for dx, right? Okay, so with these two substitutions, we can rewrite this given integral like that, right? Okay, let's keep modifying it and simplifying it. First, notice that 3 sine theta all squared can be written as 9 sine squared theta, right? Okay, and of course for dx, we have 3 cosine theta d theta, right? Here at the tail end. Okay, cool. Now, inside of the square root, we're going to factor out a 9 to start. And once we do that, we see that we'll have 9 times 1 minus sine squared theta. And 1 minus sine squared theta is cosine squared theta. And therefore, 9 minus 9 sine squared theta can be replaced with 9 times cosine squared theta after factoring out a 9 here and seeing that this here, 9 minus 9 sine squared theta, can be written as 9 times the quantity 1 minus sine squared theta. And clearly 1 minus sine squared theta is cosine squared theta. Yeah? Okay, cool. Now, the square root of 9 times cosine squared theta is just 3 cosine theta, right? And notice that from dx, we already had a 3 cosine theta. All right, so that means that this is our next step. Yeah? Okay, cool. Of course, we're going to lump these two guys together and write them as 9 cosine squared theta. In fact, we might even take the 9 out in front of the integral and just write 9 times the integral of cosine squared theta d theta. Okay, cool. Where to from here? Well, first of all, we need some space. So let's make room. Like that. And this is where we left off as a reminder. Yeah? Okay, cool. Now, I've already made a video about how to integrate cosine squared theta. And so I'm not going to do it here all over again. I'll just link that video below this one. But yeah, if you do it correctly, the integral of cosine squared theta d theta should be 1/2 times sine theta cosine theta plus 1/2 theta plus c. All right? Remember, our integral started off with x's, so we need to get back to x's. So our answer is not just 9 times this here, right? Yeah, so this is how we get back to x's. Remember, we said that x is equal to 3 sine theta. So x over 3, or x divided by 3, is equal to sine theta. And from this, we see that theta will have to be sine inverse of x divided by 3. And we need theta because, look at this, 1/2 theta right there, right? And now theta in terms of x is sine inverse of x divided by 3. Cool. And of course, sine theta, we already have right here. It's x over 3, so we know how to replace that guy right there. We just need a replacement for cosine theta. Well, from knowing that sine theta is equal to x divided by 3, we know that cosine theta is the square root of 1 minus sine squared theta, because 1 minus sine squared theta is cosine squared theta, so the square root of that is cosine theta. And so then, since we know sine theta is x divided by 3, 1 minus sine squared theta will read 1 minus x squared divided by 9. Simplify right here a little bit, like, get common denominators and use square root rules, and you'll easily see that you can rewrite this here, the square root of 1 minus x squared divided by 9, as this here. Yeah, so cosine theta in its most simplified form, and this particular case will be root 9 minus x squared all divided by 3. Cool. So we've got everything we need then. So our integral is going to be, don't forget that 9 right there, that was multiplying the integral of cosine squared right here where we left off, right? So bring back that 9. Otherwise, the rest of this stuff here is just 1/2 sine theta cosine theta plus 1/2 theta plus c. And the c we can write outside because 9 times c is still c, some constant we don't know. But yeah, like this here reads what I had in yellow as the integral of cosine squared. And we just needed to multiply that by 9. And so we have that. And yeah, so that's that. Right? Final answer. a little bit more simplified is right here, because like this 3 and 3 here in the denominator make a 9, so that gets rid of our 9 in this first part when we distribute the 9 to here. And then when we distribute the 9 to here, we're going to get 9 over 2 sine inverse of x divided by 3. Otherwise, we have our plus c. So this is it for example 1. Examples 2 and 3 are going to be much harder. And then, of course, I have 3 other examples that are even more difficult. So look out for those videos and keep watching. Take care.